Hello, my dear friends, and welcome to our today's class. It's our sixth lesson on the fourth topic of Form 3 work, which is called Work Energy, Power and Machines. As usual, let me comment by giving you the quote of the day, which states that we all have 24 hours in a day. It's how we choose to spend every second that makes the biggest difference in our life. We shall discuss that quote at the end of our class today. So today we are looking at some symbol machines, and the first symbol machine that we are looking at is what we call the levers. So this is a very good example of a lever whereby we have the pivot, or also called the turning point, or the fulcrum. Then we have the load that we want to apply some effort E in order to raise that particular load from one point here up to an upper point there. So it is important to note that the levers usually work on the principle of moments, which we studied in book 2, whereby we were talking of at equilibrium, sum of clockwise moments being equal to sum of anti-clockwise moments about the same point. So in this particular case, the most important thing is to note how to find the mechanical advantage and the velocity ratio for levers. So in this case, we want to raise this particular load L by applying an effort force E, which is acting downward. So remember that mechanical advantage is equals to the ratio of the load to the effort. So mechanical advantage will be given by load divided by the effort. So the load of this particular body that we want to raise, L, divided by the effort that we shall need in order to raise that particular body, that ratio should be able to give us the mechanical advantage. Then the velocity ratio, in this case, remember velocity ratio is always given by the ratio of the effort distance to the load distance. But in this case, now the effort distance is given by the distance moved from this particular point up to the lower point. That is the distance through which our bar moves as a result of applying this particular effort. So the distance from this point up to the new position of the bar after an effort has been applied to it, this particular distance is what we are calling the effort distance. Then the distance moved by the load. Remember, the load initially was here. Then when we applied this particular effort, this side moved downwards, and at the same time the other side, that is the load, moved upward to another position, maybe let's say position B. So the distance through which this particular load moved, the distance that the load moved from this point up to this upper point, that is what we are calling the load distance. Therefore, the ratio of the effort distance to the load distance should give you the velocity ratio of that particular lever. Then velocity ratio can as well be given by the effort arm divided by the load arm. That is courtesy of similarity. So remember, if we use similarity, we shall realize that this particular distance DE and the distance DL, remember the distance DL will be similar to the load, that is the load arm, this particular load here. That is because this particular triangle here, this triangle up to this point will be similar to this other triangle here, the triangle from this point to this point up to this point. So because those triangles are similar, so if we use similarity that we usually learn in mathematics, then you realize that the distance moved by the effort will simply correspond to the effort arm, and also the distance moved by the load will correspond to the load arm. Therefore, velocity ratio can be given by either the effort distance divided by the load distance. The effort, that is velocity ratio, can as well be given by the effort arm. That is the length of the effort arm, which is this particular length here, EA, the effort arm, divided by the length of the load arm. And the load arm simply starts from the pivot up to the point where our load is. So LA, that is the load arm. So the ratio of the effort arm to the load arm is simply similar to the ratio of effort distance to the load distance, which is equals to velocity ratio. So maybe if you are given a question, you just look at what you have been given. If you are given the effort arm, that is the length of the effort arm and the length of the load arm, you simply use effort arm over load arm to find the velocity ratio. If you're also given the effort distance, that is this particular vertical distance, and you're also given the load distance, then you use effort distance over load distance to find your velocity ratio. So actually it depends with what the question has provided. Then if two machines A and B with velocity ratios VRA and velocity ratio VRB, that is velocity ratio of machine A and the velocity ratio of machine B respectively, then that is respectively are combined. So if we combine those two particular machines A and B, then the resultant velocity ratio VR, that is the resultant velocity ratio of the two machines which are combined together, they will be given by the product of the velocity ratios of the first machine and the velocity ratio of the second machine. Then the second symbol machine that we are looking at is what we call an inclined plane. Simply an inclined plane involves raising a load from one point, maybe from the ground level up to some certain higher point, maybe up to point C. So we want to raise this particular load from point A up to point C using an inclined plane. So for an inclined plane, there is that angle which is made between our inclined plane and the horizontal, which we are calling angle theta. So from mathematics, from SOHCAHTOA, we know that the sine of theta should be equal to opposite divided by the hypotenuse. So in this particular case, if this is our theta, remember the opposite side is the side which is directly in front of your angle. So if this is our angle theta, then this will be the opposite side. Then the adjacent side is always the side making your angle, that is the side that is connecting the angle that you want to find, that is angle theta, and the perpendicular and the 90 degrees vertex. So this particular side AB is our adjacent to this angle. Then of course side AB will be the hypotenuse, which is the longest side of any right angled triangle. Therefore the sine of theta is opposite of adjacent, no, opposite of a hypotenuse. The side which is opposite to our angle theta is side BC. So BC divided by the side which is hypotenuse, that is the longest side, is side AC. Now, but side BC, if the load moves up to this particular point, it simply means that corresponds to the load distance. So the load moves from point A up to, from point B up to point C. Remember, the load distance is usually the directly vertical distance. Then this is the effort distance, that is AC. So BC is equals to the load distance, which is DL, that is the load distance, divided by AC, which is our hypotenuse. It is the distance through which the effort causes our body to move through. Therefore, we denote that by effort distance, that is DE. So DL over DE, that is the load distance, divided by the effort distance. But from up here, we are seeing that velocity ratio is equal to the effort distance divided by the load distance. But now here we have load distance divided by the effort distance. So if we take reciprocals on both sides of this particular equation, we shall have 1 over velocity ratio being equal to, that is 1 over velocity ratio being equal to DL over DE. So if you take reciprocals on both sides, 1 over velocity ratio will be equal to DL over DE. So remember here we also have DL over DE. So that one simply means if DE over DL is equals to velocity ratio, it simply means that the reciprocal, which is DL over DE, will be equal to the reciprocal of the velocity ratio, which is equals to 1 over VR. Now, if I pick the first quantity and the last quantity, we have the sine of theta being equal to 1 over velocity ratio. Then I can just put sine theta to be over 1 so that I do cross multiplication. So, or alternatively, you can also take reciprocals on both sides. So if I take reciprocals on this side, I'll have 1 over sine theta. So the reciprocal is 1 over sine theta. I also take reciprocal on this other side, the right hand side, which will give me velocity ratio divided by 1. So from this equation, remember VR over 1 is just the same as velocity ratio. Therefore, velocity ratio can as well be given by 1 over the sine theta, where theta is the angle of inclination of that is between the horizontal and the load along which the distance through which that particular load is being inclined. So for an inclined plane, velocity ratio can be given by 1 over sine theta, where theta is the angle of inclination from the horizontal or the ground level. Then the other machine that we are looking at is the wheel and axle. So what you need to know is that the wheel is usually the larger part, then the axle is the smaller part, which is actually used to rotate that particular wheel. So wheel and axle are usually connected in such a way that as the axle moves, it also corresponds, or it provides a force that will also make the wheel to rotate in with the same magnitude. So the axle is usually the smaller part here. So we are assuming it has a smaller radius r. Then of course the load is usually on the axle. Then the wheel, we apply the force on that is the effort on the wheel. Then we assume that the wheel has a larger radius r. So velocity ratio for such a system will be given by the radius of the wheel divided by the radius of the axle. So because radius of the wheel in this case is capital R, then radius of the axle is represented by small r, that is this particular radius of the smaller circle here. So velocity ratio will be given by the ratio between the radius of the wheel to the radius of the axle. Then of course, if you want mechanical advantage, you simply take load, you divide by the effort. So let's look at an example involving the formulas that we have just shown. So the first example reads that a wheel and axle is used to raise a load of 280 Newton by a force of 40 Newton. Then applied to the rim of the wheel. So if the radii of remember radii is just the plural of radius. So radius is singular, radii is plural. So if the radii of the wheel and the axle is 70 centimeter and 5 centimeters respectively, calculate part A, the mechanical advantage of the wheel and axle. So we know that mechanical advantage is load over effort. We are given a load of 280 Newton and an effort of 40 Newton. Therefore, 280 Newton divided by 40 Newton, you'll simply get a constant, which is 7. Remember, mechanical advantage is a ratio, and therefore the units do cancel out, and therefore the final answer is just a constant without any units. Then part B, they want us to find the velocity ratio. Remember, the velocity ratio for wheel and axle is given by radius of the wheel divided by the radius of the axle. And we are told that if the radii of the wheel and the axle is 70 and 5 centimeters respectively, that simply means radius of the wheel is 70 centimeter and the radius of the axle is 5 centimeter. So radius of the wheel 70 centimeter, axle 5 centimeter. So the quotient gives us a constant, which is 14. Then part C, they wanted us to find the efficiency of that particular machine. So efficiency is simply the ratio of mechanical advantage to velocity ratio expressed as a percentage. Therefore, we already have our mechanical advantage as 7. Therefore, we shall have 7 divided by that is velocity ratio, which is 14. So 7 divided by 14 times 100, or we express it as a percentage. Therefore, 7 into 14, that is 2 times 100 divided by 2, you will get 50%. So the efficiency of our machine is 50%. Question 2 reads that a man uses inclined plane to lift a 50 kilogram load through a vertical height of 4 meters. Remember, vertical height, that represents the distance moved through by the load, or the load distance. So the inclined plane makes an angle of 30 degrees with the horizontal. If the efficiency of the inclined plane is 72%, calculate part A, the effort needed to move the load up the inclined plane at a constant velocity. Remember, if we want to find the effort, we'll find a formula that has the effort in it. And we know that mechanical advantage is load over effort. Therefore, the first thing is to find the mechanical advantage of our system. Remember, mechanical advantage is equal to, that is, efficiency is mechanical advantage of velocity ratio times 100%. So that means that if we get our velocity ratio and we are given the efficiency is 72%, then if we have velocity ratio and the efficiency, we can easily find our mechanical advantage. So we are finding mechanical advantage because we know that mechanical advantage is equals to load over effort, and we want the effort here. Therefore, once we have the value of mechanical advantage, it will be easier for us to find the effort needed to move that particular load. Therefore, because we are given the angle of inclination from the horizontal, and we have just derived an equation from the our last page, and we have shown that velocity ratio can be given by 1 over the sine theta, where theta is the angle of inclination from the horizontal level. So we are given the angle of inclination as 30 degrees. Therefore, velocity ratio will be 1 over the sine of 30 degrees. Remember, sine 30 degrees is equals to a half, or 0.5. Therefore, 1 divided by a half, you will simply get positive 2, or you get 2 as a constant. Therefore, the velocity ratio of the machine is 2. Now, we know that efficiency denoted by neta is equals to mechanical advantage of velocity ratio times 100%. Therefore, we just substitute the values that we have. We are given that the efficiency of the machine is 72%. Therefore, 72% is equals to mechanical advantage, MA, divided by velocity ratio, which we have already found as 2. Then, of course, we express it as a percentage. So if I want to remain with mechanical advantage alone on this side, or if I want to make mechanical advantage to be the subject of my formula, I'll simply multiply both sides by the reciprocal of 100% over 2. And of course, the reciprocal of 100% over 2 is simply 2 over 100%. So I multiply both sides by the reciprocal of 100% over 2, so that I only remain with mechanical advantage, because the reciprocal and 100 over 2 will simply cancel each other. Therefore, the reciprocal is 2 over 100%. The other side I also multiply by 2 over 100%. So 2 and 2 cancels, 100% and 100% cancel, so that I remain with mechanical advantage. Therefore, mechanical advantage will be equal to, remember, percent and percent will cancel out. Then 2 times 72, you will get 144. Then if we divide 144 divided by 100, you will simply obtain 1.44 as our mechanical advantage. But the equation wanted us to find the effort. So we know that mechanical advantage is load over effort. Then we are told that the load is 50 kilogram. That is, the mass of the load is 50 kilogram. But we know that force is equals to MA. That is mass of the body times force is equals to mg. That is, weight is simply mg. So mass of the body, which is 50 kg, times gravity, which is usually 10 Newton per kilogram. Therefore, if I substitute the values, I'll have mechanical advantage, which is 1.44, is equals to load. So load is simply 50 times 10, which gives me 500. That is mass of the body times the gravity, or simply the weight. Then we divide by the effort that we want to find. So that we have 1.44 over 1 is equals to 500 divided by the effort. So if I simply take reciprocals on both sides, or when I cross multiply, or if I want to make effort the subject of the formula, I'll simply cross multiply, so that I have 1.44 E being equal to 500 times 1. Then I divide both sides by 1.44, so I'll obtain E, the effort, being equal to 500 divided by 1.44. So if you compute these quotient, you will obtain 347 whole number 2 over 9 Newton as the effort that was applied to move that particular load through this particular inclined plane. So this was our inclined plane. Then part B, they want us to find the work done against friction in raising the load through the height of 4 meters. So we know that the work done against friction is equals to work input. That is the difference between work input and the work output. Then we have shown from our previous lesson that the work input will be equal to effort times the effort distance. Then work output will be given by load times the load distance. So now what we do, we just need to have all these values. So we were given effort. We have just found effort from our part A, which was 347, 2 over 9. Then DE, that is the effort distance, we don't have it. So we simply use the information that we have to find the unknown. So the effort distance, so from this particular diagram, you can see if this is 30 degrees and this is 4 centimeter, the effort distance from SOHCAHTOA, the relation that will relate 30 degrees, DL and DE is simply the sine. So we know that sine theta is equals to opposite of a hypotenuse. Therefore, sine the angle, our angle is 30 degrees. So is equals to, the opposite is DL, which is 4 divided by DE, or the effort distance. So if I do cross multiplication, I'll have effort distance times sine 30 being equal to 4 times 1, which is just 4. Then if I divide both sides by sine 30 degrees, I'll have DE being equal to 4 divided by the sine of 30 degrees. So 4 divided by, remember, sine 30 degrees is 0.5. So 4 divided by 0.5, or 4 divided by a half, we'll simply get 8 meters as our effort distance. So now once we have all the values, we can easily compute whatever we want. So work done against friction is simply the difference between the work input and the work output. So work input is the effort times the effort distance. So the effort, we have calculated it as 347 whole number 2/9 Newton, times the effort distance, we have found it as 8 meters. Then we subtract the work output, which is equals to load times the load distance. So our load was 50 kg, but we know that that is the mass of the load is 50 kg. So the weight or the load is equals to mg, that is mass times gravity. So mass of 50 kg times gravity, which is in 10 Newton per kilogram, that is the gravity on Earth. Then times the DL, that is the load distance, so times 4 meter. So this gives us, that is 347 whole number 2/9 Newton times 8. You will simply get 2777 whole number 7/9 Newton meter, or joules. Remember, we said that 1 joule is equals to 1 Newton per meter from our first lesson. Then 50 times 10 times 4, you'll simply get 2000 Newton meter. So the difference between 2777 whole number 7/9 and 2000, you will get 777 whole number 7/9 Newton meter is our work done against friction, which is approximately equal to 777.8 joules. Remember, 1 Newton per meter is equals to 1 joule. So the work done can be given in Newton meter or in joule. Then finally, I have an exercise here that I do recommend you should try at your own free time to gauge whether you have understood the questions that we have handled. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that we all have 24 hours in a day. It's how we choose to spend every second that makes the biggest difference in our life. So the quote is just reminding us to spend our time wisely, to spend our time wisely. If we want to be, that is to spend our time wisely, if we want to be valuable people in our society. Also, our future depends on how poorly or how well we choose to invest the limited time we have today. Yeah, that is, make sure that you are using your time well, so that you invest your time in doing something that is productive, so that within a given period of time you will be able to reap the benefits of your efforts. And lastly, remember that if you don't make time to work on, that is, if you don't make time to work on creating a life that you've always wanted, then you will be forced to spend a lot of your time dealing with a life you didn't want. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you will get notified. Thank you very much for accompanying me up to this particular point. This is Kind Tuition Academy. Until next time.